Hey, this is Chapter 5, Frequently Asked Questions. Let's begin. Question number 1. How do I write an equation of a line given the slope and the y-intercept of the line? And we'll write the answer or the equation of this line in slope-intercept form, y equals mx plus b. So what we want to do is substitute the slope in place of m and substitute the y-intercept in place of b in this equation right here. So, for example, write the equation in slope-intercept form of a line with a slope of -3 and a y-intercept of 7. Whoa. So, slope-intercept form looks like that. Let me try that again. So I need to identify the slope and the y-intercept. Let's see. A line with a slope of -3 and a y-intercept of 7. So -3 will be my m value, as that's the slope, and 7 will be my b value, as that's the y-intercept. So the equation would be y equals -3x plus 7. There we are. How do I write the equation of a line given a graph of a line? Frequently asked question number 2. First, you're going to calculate the slope by identifying 2 coordinates on the line. So, like for this first example, I know the exact coordinates of that is 0, 1. I know the exact coordinates of, say, that point right there is 2, -2. So you can either use your slope formula and take, let's see, 1 minus -2 and 0 minus 2, and chop chop, you get 3 over -2, which is the same as -3/2, and that's your slope. That's one way of doing it, and that's absolutely okay to do it that way. Or you can build your rise run triangle. The rise is 3, the run is 2, so you have to put it 3 over 2, and by the way, the slope of this line is totally negative, so you need to make it a -3 over 2, because if a line goes down as we move to the right, it's a negative slope. So whichever way you want to identify the slope as -3/2, do that. And then step number 2, I guess that 1 and 2 I kind of tied together. That was calculating the slope. Step number 3, identify the y-intercept. Y-intercept, where the line crosses the y-axis, it's at 1. That's your b value. So the equation of this line is, drumroll, y equals -3/2 x plus 1. See what I did there? I substituted the slope in for m and the y-intercept in for b. Let's try it one more time over here. Identifying 2 points that the line goes through. How about there? -2, -4. And then right there, -1, -3. So it looks like we're going up 1 and right 1. So the slope is 1 over 1, which is really just 1. And the y-intercept here is -2. So that's your b value. So now substitute these into slope-intercept form. So 1 goes in place of m, and -2 goes in place of b. Now that's a decent looking equation. But the best answer, and the one that it's going to look like on like a multiple choice test like the ACT or anything like that, they're not going to write the multiplier of 1 there because we don't need to, and then instead of writing plus a -2, they'll write -2. So this is the most simplified, the best way of writing it, but my initial answer is also a good and equivalent answer. Question number 3. How do I write equations of horizontal and vertical lines? Like, I look at this first example and I'm like, oh my gosh, that's scary. What's that equation of the line? Well, recall, vertical lines cross the x-axis. And the equation looks like x equals whatever the x-intercept is. And this line is a vertical line, and it crosses through the x-axis. So it's going to be x equals, and then ask yourself, what is the x-intercept? It's at -1. Because, and why this is the equation of that line, folks, is it doesn't matter how high or how low the y value is. No matter what, x is always -1 at all these points. That's the rule for any point that's on this line. They don't even talk about y, because y can be anything, but x is -1. Whereas, if we have a horizontal line, if it's a horizontal line, it's going to cross through the y-axis, and the equation will be y equals whatever the y-intercept is. So let's see, the y-intercept here is 2, so it's going to be y equals 2. That's it. No matter what x is, no matter how far to the left you go, how negative x is, or how far to the right you go, however positive x is, and big x is, y is always 2. So there is your answer to that graph's equation. Question number 4, how to use point-slope form. Point-slope form is great if you have a point on a line and the slope of the line. If you know a slope and if you know a point, then you, oh, I was supposed to use a different color there. I was getting all jazzy and I goofed up. If you know a point and you substitute the coordinates of the point in for x1 and y1, and you substitute the value of the slope in for m. Now, that's a great first step. Then you use a step that you're all familiar with. You distribute on the right side, and then you get y by itself by undoing some addition or subtraction. And then that will miraculously get the equation in slope-intercept form. And by the way, the cool thing about this is you can graph the line in the problem described. And you should see that the equation that you get by doing the algebra should match the equation of the line that you graphed. And if it doesn't, it means you made either an algebraic mistake or a graphing mistake. It's pretty sweet when the two things match up. It means you're very likely 100% correct. Likely. Example here, write the equation of a line with a slope of -2. So I'm going to write m, and I'm going to point up to that -2 because that is my m value. And it goes through the point 3, -1. So that's my first x and that's my first y. And those things will go in place of the green highlighted areas right there. I'm going to rewrite point slope form here. You don't ever need to do that, but if it helps you, do it. So let's see, I'm going to have y minus -1. And if you know that you can just put +1 when you see a negative coordinate because we're going to be subtracting it anyway, you can do that. The slope is -2, so that goes in place of m. And then we have x minus whatever our x value is in that point, which is 3. So over here, I'm going to chop. I like to add the opposite. Subtracting a -1 is the same as adding a +1. And in the parentheses, I find that when I distribute, I want to see a plus sign there. It helps me do the math better. I don't make as many mistakes. So I'm going to add the opposite there as well. So once you substitute, distribute on the right side, right here. So this -2 is getting multiplied with the x, and the -2 is getting multiplied with the -3. So we get -2x. I'm going to drop the plus sign down, the operation right there. And then I get -2 times -3 is +6. On the left side, we have y plus 1. So after I distribute on the right side, get y by itself. Y is being added by 1. So to undo that, I'm going to subtract 1 on the left side. But what I do on the left, I have to do on the right. So now I get y equals -2x plus 5. And you should find that if you graphed a line that went through the point 3, -1, on your test, I will provide a graph for you. So I did not hear, so Mr. P is going to rough sketch this. And I have a slope of -2. So that means down 2, right 1. But it also means up 2 and left 1. So I'm going to go up 2, left 1, up 2, left 1, up 2, left 1. When I do that, it puts me on the y-axis. And so let's see here, this line, when I graph this information, that's what I was graphing, folks. I started at the point 3, -1, and then applied the slope of -2 through that blue dot both ways, down 2 and right 1, and then reversing that slope up 2 and left 1. I use the slope of -2, and my equation says I have a slope of -2. But then the real big question is the y-intercept actually 5 when this information happens? And you bet it is. It's +5. Boom. So I'm feeling really confident in that answer. That makes me happy.